Bismillahirrahmanirrahim. Assalamu alaikum. My name is Engineer Zarif Khan. Today I'm going to present about strip foundation or wall footing design. This is very important topic, and we will discuss about the wall design, its analysis, and then steel reinforcement details, the wall footing thickness, its shear capacity. So typically in the wall design, the engineers do two mistakes. Like, first of all, its thickness, the footing thickness, how much it should be minimum, and then the reinforcement in the foundation. So we will discuss all in detail. This is very simple and very easy, and every engineer can take it and make their spreadsheets. I will share this spreadsheet with you. You just take it and make your own design as well. So first of all, in the foundation design, the engineer should focus on the loads, which loads are coming on the wall, on the foundation, sorry. So usually on the foundation, the wall load is coming, and that's due to live load and due to superimposed dead load, and also the self weight of the foundation as well. So for that, the engineer should know about the bearing capacity of the soil. That is very important, that engineers should study the geotechnical report conducted by the soil testing laboratory firms, geotechnical engineers. They go to the site and take the samples, and they test it for shear test and some other test, moisture content test, and its bearing capacity is calculated as per the formula given in the books. This here we will not discuss about the bearing capacity testing, but here we need just to know that the engineers must be aware of the bearing capacity value of the soil for which the building is being designed. Typically, the wall footing we design for the houses and for the small buildings, in which the load bearing walls take all the loads, and that load is transferred to the foundation. So this is not typically done for the frame structure. This is done for the brick masonry wall buildings. Here we will take this is a simple shape. The wall footing foundation looks like this. This is the soil, then the PCC on the soil, then RCC, and then the brickwork is being started. Then there's plain beam and so on. So first of all, we will start from the loads. The load comes from the walls. The engineer should calculate how much load is coming on the foundation footing. Here we assume that service load, dead load on the wall is 5.5 kip per feet. Usually in the footing design, we take the load per feet. So, and we will take separately both, because the factor multiplying by, like, as per the factors which are multiplied to these loads are different. For the live load, this is 1.6, and for the dead load, this is 1.2. The engineer must know about this, that we should take these dead loads separately. So here we take, suppose our load is 5.5 and the live load is 1.6. We can make it 5 even, 5, we can make 2. So this is the load criteria. Then after that, this load factor load is being calculated. This is the factor load 9.2. You can see that has been multiplied by 1.2 and 1.6. Okay, so the factor load is 9.2. The bearing capacity here we take in kips per square feet, that is 2.0938 kips per square feet. Suppose here we have this 1 ton. So for 1 ton, suppose we take this 1 ton. So 1 ton is 2.204 kip per square feet. This is 1 ton bearing capacity. Okay. Then the concrete compressive strength we need, material properties. We take this here, 3000 psi strength. Okay. Then the tensile strength of steel, we will take this as 60,000 psi. Depth from FFL, this foundation is deep from the finished floor level 1.5 feet. Let's make it suppose 4 feet. This is important because the soil below this foundation will be like deducted, that much load will be deducted, and this extra, like the foundation coming on this soil, it has impact, so that we have to deduct from the bearing capacity. So that much bearing capacity will be reduced. Okay, clear cover. Okay, then coming to the thickness, footing thickness. In the footing, the design of the footing, we will start from an assume value. Suppose we assume that the thickness, 9-inch thickness here will work, and we will check its capacity. This thickness is for the punching shear. So later on you will know that why we use this 9-inch, why not 6-inch, why 8, 5 and 10. So minimum thickness should be 9-inch in the wall footing. No thickness should be less than 9-inch. This must be understood by the engineers. 9-inch is minimum thickness for the wall footing as per code requirements. So let's say we start from 9-inch. We will check. If it works, it's okay. If it doesn't work, so we will repeat and we will revise the section. So 9-inch thickness assumed. Clear cover in the foundation usually we give as per code 3 inches. Okay, this is automatically calculated, the effective depth. And now weight of the fill. So this is weight of the fill, which weight is coming on the foundation. We have this concrete and this soil. So this much soil is being deducted and calculated. This weight of the soil, the fill, so I mean the soil plus concrete. Effective bearing capacity will be reduced because of this weight of fill. So this is 1.739 kip per square feet, calculated automatically. Then bearing area. So according to this, the bearing area for the wall will be 4.05. Okay, this is square feet. So this is the bearing area. The bearing area, actually this is for running feet. Okay, for running feet, this is square feet, like 1 feet by this width. So it means that 4.05 is the area required here. It means let's assume this bearing area, according to the area, we assume the width is 4 feet. Okay, this is a little bit more, 0.05 from the 4, but let's assume this is 4 feet. Let's see what happened. After that, the bearing area is 4 feet, is okay. Now we have to check the punching shear. The factor pressure we will calculate. There's formula for the punching shear. This, so total area, this and the area we provided divided by this factor load. So factor load will be divided this area by factor load. It will give you this factor pressure. Okay, then value of K is calculated, like the center of like this moment arm. This is the centroid of the wall footing. Okay, and from that we will calculate this K. Okay, what is this K? This is actually the centroid center point of this footing. Then we will check the punching shear. For the punching shear, we have this formula, which is 75% of actually this is punching shear capacity of the assumed footing. This is 5.4. This is actually 2 into FC prime under root into BD, and here we will divide by 1000 because this is in foot, so we need kips. So shear capacity is 5.4, thickness is okay. This is formula that if this is less than the other one, so it means this is the shear, this is the shear demand, okay, and this is the shear capacity. Shear demand here is 2.6 and the shear capacity is 5.4, so almost double. So our assumed thickness is okay. So we should go further that the thickness is okay, and now the flexure design, flexure reinforcement we have to calculate. For that we need to calculate the moment. The moment we can calculate by this formula, that this moment arm multiplied by total force coming on the factor load on the this foundation. So this is actually like we have to take at the middle point. So the factor load D19 is this is the K multiplied by this factor pressure, 2.3 into K by 2. This is 3.03. This is in kip and this is in kip inches, 36 inches. Okay, now come to the reinforcement calculation. According to this, the reinforcement comes to be 0.13 for this footing, and in our case the minimum area required is 0.018 into B into H. Okay, so it means that 0.94 is more, so provide minimum steel area in the foundation. So the minimum is 0.19. Bar spacing comes to be 12 inches. It will if we use number 4 bar. So let's see, provide 9 inches, and the distribution bars comes to be 12 inches same, and let's provide 9 inches. So this is simple equation, simple formula we can use in the design of the footing. Okay, suppose we change the properties. Here we take it 8 kip, and we also change the lie load here 1 point, this is 2, let's make it 2.25. okay, so this will be changed. This is 13 and this 3000 same. Let's see what area comes to be. This is 5.92, so it means this will be, we will need 6 feet here. The 6 feet will be required depth. Okay, similarly factor pressure. Now the shear check, the demand is 4.7 and the capacity is 5.4, so thickness is okay, no problem with the thickness. Let's see the flexure reinforcement changes. So we will see here, let's see, this is 0.32. okay, so 0.32 is the required area and the minimum steel is 0.19. So we will go to the actual area. Actual area is this one, 133. According to this, the spacings comes to be 7.2 inches, but let's see, for the safe side we will provide this 6 inches. by using number 4 bar. Okay, and this is distribution bars is the minimum steel. Let's provide here 9 inches. So this is the shrinkage reinforcement 0.18 BH. So everyone can make their own, but the important thing is this load. This load should be calculated first. That this, if the building is single story, so it will be calculated according to that. If the building is 2 stories, so it will be calculated according to that. If the building is 4 stories, so we have to take the 4-story load on this foundation. Okay, similarly, if this is increased, okay, I take it 10, suppose in some cases there is 10, and this is 1.6, suppose. So this is 14.56. Again, the same capacity, suppose I change this to 2500, and this is 40, let's say it's 60. Okay, start with the minimum 9 inches. Okay, so minimum is 9 inches. We start it, and let's see what happens. Let's see what happens. This is 6.7 now. Okay, so go for 6.75 inches. This green we have 2 feet. Okay, now let's come to the shear capacity. So now you can see here that 5.4 is the demand and the capacity is 4.95. It means that this is not working, so it gives you warning, increased thickness. Increased thickness mean thickness is not working now. So then we have to go back, and we have to take this change this 9 to suppose 10 inches. I change it to 10 inches. Let's see what happens. So now the area is same, but the thickness is okay now. So this 10 inches will work now. 5.85 and this 5.2. So shear capacity is okay, satisfactory. 10 inches will work here now. Then come to the flexure. Again, see the moment. The demand is 954, 113 kip inches. The area comes here 3.34. Okay, so go, the minimum area is 0.21 because the thickness changed, and similarly 0.34 will work. We have to take the maximum of this. Here again the spacing comes to be 7, but we provide 6 inches. This is 11 inches, we provide 9 inches. I think it's done now. So in the wall footing, the main reinforcement will be in the short direction like this, and the distribution bars will be in the longitudinal, and these dots are in the long bars. This shrinkage reinforcement or distribution bars, and the main is in the short direction. So provide the L according to the requirements. 6 diab bar, 12 diab bar. This L should be 12 diab bar at least, and we should think about if the thickness is this, so we have to take provide 90 or 180 degree hook. So I think it's done now. Everyone can take this sheet. I will share the sheet in the with the video. Watch this video and learn from here, and then take the sheet and go for your design. But always check with the senior engineers as well when you do some design. So never trust on that until the analyst check by some senior engineer. This is just for to make easy the foundation design and to make the wall footing thickness and reinforcement. Okay, so let's go for the actual. I have put the formulas and all the required documentation. Thank you so much for watching this. Share with the friends, and give your feedback, your remarks in the remarks section. Thank you so much, and Allah Hafiz.